Hey everyone, my name is Ed, and this is going to be the first of a few videos I'm going to be doing on programming. Now, before I started this video series, programming in particular is a topic a lot of folks asked me to cover. I'm hoping this video format is something that the teams who ask can find useful. So today what I want to talk about is controlling a motor to a position. And what this technique can be used for is, for example, controlling something like a linear slide. This is the Viper slide from GoBuilda. Let's say I want to extend this to a certain position. The technique I'm showing will let you do that. You could also use it in the case of a geared arm like I have on my demo bot to rotate this arm to a position and kind of hold it there. This technique I find really useful for simple robots like this. Even for more advanced robots, this technique is very powerful and it's very flexible. So with that said, I'm going to show you the demo bot and then we'll get started on the programming. The way I like to program these arms is to be able to hit a button and have the arm kind of automatically move to some pre-programmed position and hold itself there. Now to do that, we're going to use the encoder that's built into the motor. Now if you saw my wiring the robot video, you'll know that we wired up this motor with the encoder. The first thing I'll do is I'll show you how to set that up in the code to be able to show the position of the motor on the driver hub. And basically what we'll do is we'll record a few positions that we'll want to control the arm to, and then we'll use that to control the arm. Alright, to get started, what I'm going to do is connect to the robot. Next, I'm going to open up a web browser. I type in this web address. This is 192.168.43.1:8080. And what that's going to do is it's going to open up the web interface. And I like using this because it's a little bit more screen space and it makes it easier for me to use. So I'm going to click on blocks. I'm going to create a new op mode. I'll give it a name. And I'll select basic op mode as the sample. And click OK. And now we have the actual programming interface. I'm going to hide the Java because we don't need to see that right now. And one thing I recommend is bookmarking this tab so that it's easy for you to find later. To get started, I'm going to put a comment block here. I'm going to put the comment arm setup. All I want to do is print out the current arm position onto the screen. Going to Utility, Telemetry, and I'm going to grab this block and put it there. Now, what is this doing? This is going to print out information onto the driver hub. This text will show up on screen, as well as whatever value is computed here. Now, what value do I want to get? I'm going to go to Actuators, DC Motor, and actually grab the arm current position. And this is just going to print it out onto screen so I can see it. Some other stuff we'll do is I'll grab DC Motor again. I'll grab this direction to be reversed. So ultimately what I like to do is when the arm is at the starting position and rotating upwards, I like that direction to be the positive direction. If it's not the positive direction, you can change this from forward or reverse. Just change it to the other one, and that'll flip the direction of the motor. Now every time I turn on the robot, every time the code starts up, I want the arm to be at its 0 position, and I want the encoder value to be 0. This will make sure my set points are all consistent. So to do that, I'll go to DC Motor. I'll grab this run mode, and we'll click stop and reset encoder. And then the next thing I'll do is I'll grab this block here, and I'm going to set the arm to brake mode. Great, so that's going to be fine to get started. What we'll do is we'll click save op mode, and then I'll boot up my driver hub here. Okay, with the robot turned on and the arm in its starting position, which is in this case downwards against this hard stop, what I'm going to do is grab my driver hub, and I'm going to select my code by hitting our drop down arrow. I'm going to select ARM demo, which is our code we're working on, and then I'm going to press init. That's going to start our code, and then I click play to actually run it. And we'll see on our screen we have some text in the upper right that says arm position. So now when I grab the arm and rotate the arm, say go upwards like that, we see arm position actually has a value now. Now you see when I rotate upwards, the value is decreasing, which I don't love, so I will change the arm direction. Then you also see if I lift the arm and release it, it does go down, but it's going down much slower. That's the arm in brake mode. What I'll do is I'll head over to code and we'll change that to coast mode just so you can see the difference. I'm back in the code, so I'm going to change the direction to forward. That'll change the value being negative. And then we'll change this to float and show you the difference with that. Click and save. With those two changes, I'll hit init and start. So my code is running again. You'll see when I lift the arm this time, arm position is now positive, which is what I want. And now this time when I lift the arm and let go, see it drops down much faster. That's the arm in float mode. And next what I'll do is I'm just going to rotate all the way around. And in that position, my arm position says it's about 1800. Closer to 1900. So we'll say 1800 will be our max. And then I'll go to just a few other positions. There is about 1200. There's about 500. And home would be pretty close to 0. So we'll go ahead and write down those values and we'll use that in our code. So now that we've seen how to actually get values from our robot, let's start using them. The next block I'm going to add is DC motor. Select this run mode, drop it in between stop and reset and the 0 behavior. We're going to click run to position. Now the order of these blocks is important. If you don't get this order right, the code will crash and that's not good. So we'll click run to position and we'll set this back to brake mode. And next I'm going to set DC motor. I'm going to grab this power and we can change this between 0 and 1. 0 will be no power applied to the motor. 1 will be max motor power. I generally like to start low, 0.5, 0.4, something like that to start. I don't like testing with full power. Now I talked a lot about getting these values, getting these positions, but what do we do with them? Well, I'm going to go ahead and create a variable. And I'm going to call this the set point. And what that means is this is the position I want the arm to go to. So we'll go ahead and drag this to the side here. And what I'm going to do is I'm going to program this so when I press a button on the controller, I'm going to change what the value is and have the arm move to that value. So to do that, I'm going to go to gamepad. I'll grab gamepad and this D-pad option. And then I'll also go into logic, which is over here, and grab this if. So I'll put that right there. If what? Well, if gamepad1 dot, let's go D-pad left. Then what? Change set point to, change it to a number. I'll go to math, grab a number, and let's say that'll be my kind of lifted up a little bit position. I think that was around 500. And now I'm going to right click duplicate and that'll drop a duplicate of that block. So I can drag this in. And now I can say D-pad up. Make that 1200 position or so. And this time I'll just click on the block and hit Control C and Control V. That'll copy paste the block. These are just good shortcuts to know. I'll go D-pad right. Make that all the way rotated position, which I believe was 1800. And then I'll Control V again. And I'll make this D-pad down. And I'll change this to, let's go 20. I don't want to go all the way to 0 because 0 is my hard stop, and I don't like running the motor directly onto the hard stop. And also in that position, the wrist tends to drag on the ground a little bit, so I want to lift it up a little bit above there. One more thing we're going to do. We need to actually tell the motor to move there. I'll go to actuators, DC motor, arm target position. I could make one of these in each side, each of these if statements. I'm going to go ahead and do it at the end here. And then what position do I want to do? Go to set point. Okay, and it's going to do that every loop. So every time our code loops, it'll set that set point. So anytime we trigger a new one of these, whichever if statement we trigger, our set point will be updated, and then we'll set that. I think one other thing we'll do is just to make sure we don't have any silly errors. Up at the top, we'll just initially set it to 0. Go ahead and save, and let's run that and see what happens. Okay, I've set up my game controller to be gamepad 1, and the D-pad are these buttons on the left-hand side. This is D-pad down, left, up, and right. I tend to use these for my arm positions. So to get started, let's go with left. Okay, my code crashed. What's actually happening here? You must set target position before switching to run to position mode. Okay, that's important.
We'll click OK. And let's go fix that real quick.
So the error I ran into was it says I need to put this, and I need to put that before this run to position mode. So I'll drag this up here, and that means I can delete that block, save.
Okay, let's try this again. I hit init, start, and nothing's crashing yet, so that's good. Now I'll press that left button. That looked good. I'll press up. That looked good. I'll press down. And that's that down position. And I'll press my right, which I believe is all the way over. Yeah, that looks pretty good. Now I am noticing the motion is pretty jerky. So maybe I could decrease my motor power a little bit. But you can see the power of this system. All I have to do is tap a button, and the arm is moving to a position and holding there. And just to test that 20, that looks pretty good. I can move the robot around, and that grabber is not actually like dragging on the ground. Now, in this position, the intent for this gripper is to be against the ground, and these would rotate and pick up the game piece. I see I have a bit of a gap here, so I think what I'll do is I'll increase this a little bit more. You can see we programmed that position to be 1800, and you can see we're hovering right around there, plus or minus a few. So I'll go ahead and press the home button. Yeah, like that.
So that was pretty good. I think the one change I want to make is I'm going to change this to 0.2. Seems like my arm has plenty of force to lift itself, so I think 20%, we can kind of see how that goes. And this value here, this 1800, I believe it was actually 1880 or so. I think that'll get my arm closer to the ground, and we'll see how that goes.
All right, so I'm going to run my code again. Init, start, and I'll press down. It lifts up, which is good. I'll hit sideways. You can see my arm moves much slower this time, but it's also not like rocking the entire robot. Yeah, I like that. That puts my gripper right up against the ground, which I like a lot better. Yeah, I'm a lot happier with those motions. And this is my technique. Basically, once I have the code set up, all I have to do is tweak the numbers, adjust them up or down as I kind of see fit. A great way to do this is to take your robot to a practice field, for example, at your competition. You can kind of guess your set points ahead of time, and then you can dial them in on a practice field before your actual matches. And this technique, again, works really well. All I have to do is press a button, and the arm just kind of magically moves.
One more change I want to make. I think the very first thing I want to do is, once I hit the start button, which would be here, I'm going to set the set point to 20. And what that'll do is when I hit that play button, the very first thing it's going to do is lift the arm a little bit, so that way I don't actually have to hit the button myself. So it's very important to put it here above the while loop, so that it only triggers once. And then for the purposes of demonstration, I'm going to change this to 2000, which we know is beyond our physical limit. And I want to show you what happens when I do that.
All right, so what this time we should see is when I hit play, the arm should immediately lift up. And it's very gentle, but it does. So now I didn't have to hit the button to do that, but it only triggered once. Now, let's trigger that far position, which is going to be beyond the physical limit. Rotates over. Okay. Now in this position, if I lift this is pretty hard locked against the hard stop. So what'll happen is this motor will consume electricity. It'll convert that electricity into heat, and it'll actually start heating up, and it can get very hot. Hot enough to smoke, hot enough to burn yourself if you're not careful. So it's very important when we're running to position like this, we need to be aware of what our actual limit of rotation is, and make sure we're not jamming the motor against that limit. Now, an important caveat for this control method. Here, I'm controlling the arm off of a gear system. So the motor has a small gear, the arm has a big gear, and they mesh together to allow the arm to move. If this gear slips off the shaft, for example, or forward on that shaft and no longer meshes, that means the motor will turn, but our arm won't. Similarly, if the shaft that holds these upper gears on, for example, comes off or comes loose and they no longer mesh there, that can also be a problem. The other thing I want to point out is this whole arm is controlled by one motor, and that's fine in this case because the arm is light enough. However, if we find that the arm can't actually move because it's too heavy, you may have to either change the gearing here to give it more torque, or you may have to actually add a second motor. In this case, I could add one on the other side to increase the amount of force I can lift that arm with.
So we'll go ahead and change this back to 1880. And from there, our arm code is basically set. This is, again, the technique I like to use when controlling a motor to position. So one other thing I'll show you is, what if I actually have to control two motors? Well, I don't have that on my robot, but let's say you have it on yours. What I can do is I can go under DC motor and click the drop down and click on dual. You see, we can apply all these same techniques to two motors at once. So I can take this block and say arm.run to position, and maybe my motors were called like arm A and arm B. I could change both of these to run to position. Then I could set them both to brake mode. And I could set the target position on both of those. And I could set the power on both of those at once. So it's really the same overall structure, just using these dual blocks to control two motors at once. This is a fairly straightforward way to do that. And of course, if you're doing all that, don't forget to also update it here to work with your two motors. As always, I hope you found this useful. I'm going to be doing a few other videos on programming, and if there's anything you want to see, go ahead and let me know. Till then, take care.